All right. So when we are talking about rigid motions and congruent figures, we're largely talking about translations, reflections, rotations. All of these are considered rigid motions. And even their compositions, when we combine different combinations of translations and reflections, also create rigid motions. We can also use that knowledge that one figure created another through a rigid motion to prove that they are congruent. So if we know that one figure is a translation of another, and we know translation is a rigid motion, it therefore proves that the two figures are congruent. So what we're going to do in this first problem is we're going to identify which figures are congruent. We're going to make sure that the vertices are matched up with their corresponding vertice. And we're going to explain how we know they're congruent based off of the transformation that would map one to the other. So let's go ahead and start with A, B, C, D. So this quadrilateral, A, B, C, D, is going to be congruent to, and we would choose this square. Now, I'm going to say that A is the same as the N. So same way as I started with A, I'll start with N. P would be corresponding to B. So I'm going to do NP, Q, R. All right, so there's my congruent statement. Next, I want to show how I know they are congruent. So this seems like a very simple translation where we went 2 to the left and 6 down. So I know these are congruent because this is a translation that follows the rule that x goes backwards by 2 and y goes down by 6. All right, next, let's go ahead and do EFG. So the triangle EFG is congruent to the triangle. Now E is going to be the same as K. So I'll put K first, and then F, which was up here, looks like it's the same as L. So KLM. And this was a reflection. Okay, we were reflecting off of the x-axis. So reflection off of the x-axis. And that's what proves that those would be congruent. All right, finally, IHJ. So the triangle IHJ is going to be congruent to. Now, there's actually a couple ways we can go about this one. The way I'm going to start is with another reflection. So if we are going off of the line y equals x, then H would map to U, J maps to S, and I would map to T. So since we started with I, we would go T, and then H maps to U, so TUS. And this is a reflection off of the line y equals x. Now, we could have approached this another way with a rotation in which I had rotated around 180 degrees to T, J rotated around 180 degrees, and H had rotated around 180 degrees to S. So we can go and say that the triangle IHJ is congruent, but notice how this needs to change now. I still goes to T, but J went to, but H had gone to S. So we do TSU. Okay, and that is a rotation of 180 degrees. Okay, all right. Now, a congruence transformation is just a combination of rigid motions. Now, rigid motions and congruence transformation, these two phrases are interchangeable. But what we're going to do in this problem is identify what combination of transformations could take us from A, B, C, D to E, H, G, F. Okay, or E, F, G, H, sorry. So first thing, now there is more than one answer. I am going to propose one specific one, but this is by far not the only way to do it. So first, I'm going to start with a reflection. Okay, and that reflection off of the y-axis. Okay, and so as I reflect A, goes there, D, C, B. All right, and there's my reflection. Now it looks, for us to go down the other way, looks like I just have to go down 4 places. For each of those points, we just have to move them down 4 places. So this should now be a translation. That is following the rule that xy becomes x. Now x doesn't change because we didn't move forward or backwards, but y went down 4 places. So these are the rules that would create that congruence transformation. All right, so now let's think about if we combine two things like reflections. Now, what we're really looking for here is if we use two transformations, perhaps they might look like a single other transformation. And that's what we're going to see with these reflections. So go ahead and build just an idea in your head. Think about this A to B and how it ends with A double prime, B double prime. So what kind of transformation, if you ignore everything in the middle, would take us from there, from the pre-image to the image, to the one right at the end? Okay, well, it looks like a translation, like it was just moved to the right. And that would be correct. So what creates this is 2 reflections. So first, we reflect over K. Now, one thing that happens in a reflection is your left becomes right, your right becomes left, just like when you look in the mirror. Same thing happened here. This was going up and to the left. Now it's going up and to the right. Now we're going to reflect it over another line. It is important to note what the relationship between those 2 lines are. They are parallel. So when I do this second reflection across a parallel line, once again, that switch between left and right happens. And it was going up and to the right. Now it's going up and to the left again. It has created the same figure facing the same direction. Only difference is it's moved to another location. Okay, so reflecting off of 2 parallel lines is the same as a translation. Now let's quickly look at what about the distance? With translation, we care about how far it went. So we need to look at that. So let's assume some numbers. Let's pretend this is 2 and that's 4. Now, because these were reflections, well, let's first start with this. So the distance between our two lines would therefore be 6. Now, because it's also a reflection, this 2 here also meant that that was a 2 there. And this 4 here means that this was also a 4 there. So my 2 plus 4 doubles to find the ending distance. And that's what they're trying to say right here, that to go from the pre-image to the ending image, all we need to do is multiply the distance between the lines by 2. Okay? Or the distance of this overall was 12. Another key thing to note is that the line between them is going to be perpendicular to the parallel. All right. So we've got a very similar situation right here, and we just need to analyze it a bit. So in this diagram, the reflection is matching GH to G prime H prime as it goes over K. Then that goes over M to become G double prime H double prime. Okay, they also tell us that HB is equal to 9 and that DH is a 4. All right, so we know those distances. So name any segment congruent to each of these segments. So let's start with the GH. So GH is going to be congruent to, well, so GH will also be congruent to G prime H prime because they are reflections, which is also going to be congruent to G double prime H double prime. And we found the ones congruent to that. Next, HB. So this distance of going from H to B, well, that's going to be repeated in the H prime to B. Okay, we have that same distance. So HB is congruent to H prime to B, meaning that this must also be 9. Finally, GA. So GA is going to be congruent to, oops. So GA is right here. So same thing. So even though I don't know the numbers, it's just going to be the same as the G prime to A. All right, next it's asking, does AC, let's see, so where is AC? All right, so AC goes here. So AC is essentially the distance between those. Does AC equal BD? Well, the answer is yes. And it is because the lines K is parallel to the line M. And because they're parallel, they're always the same distance from each other. And because all of these are right angles, those lines are creating the shortest distance to each other. So by knowing that they are parallel, we know that those two distances must be the same. So what is the length of G to G double prime? All right, so here's what we know. We kind of know that AC and BD are going to be the same. Now, we can actually figure out what BD is. We were given enough information. We got 9. That should be 4. So BD must be 13, which means AC must be 13, which also, from what we learned above, to find the distance between 2 points in this translation, it's just going to be double whatever the distance was there. So I don't need to know all of those distances. If I know the distance between K and M is 13, G to G double prime must just be double that. So the length is going to be 26 units. Now, this is if the two lines were parallel, but what is going to happen if the two lines are intersecting, if they cross? Well, if they're intersecting, what is then created is a rotation. Okay? The rotation is also going to have a similar element to it. The same way that the length in between the lines doubled to tell us the length of the translation, the angle in between these two lines, x, is going to help us to know what the angle of rotation is, which is going to be double once again. It's going to be 2x. Okay, so think of it this way. That middle angle x, let's go ahead and chop it in to 2. If it'll let me. There we go. All right, so over here I've got, we'll call it the black angle, and over here we've got our red angle. We don't know what those two angles are, but we do know that because this was a reflection, then over here that black angle will have repeated again. So we've doubled that part of it. And over here we're doubling that angle as well. So in order to know the full angle of the rotation, it's just double whatever the angle in between the lines had been. All right, so in this final problem, we got a blue fish. It got reflected over K to become the red fish. Red fish gets reflected over M to become green fish. We notice that there is a 70-degree angle between those two lines. So it is a reflection, or it is a rotation that is taking green fish over to the blue fish. Let's see if I can get that to work just right. Hopefully it did. Oh, it's so close, but my center got a bit off. Too bad. Anyways, me drawing it isn't going to work too well, but that is a rotation. Took it over there. Now, in order to figure out what is the angle of that, just like it said before, it's got to be double the angle there. So it'll be a rotation of 140 degrees. All right, good luck on your assignment.